Good morning, everybody. Welcome back to lecture 35. The average of the major exam is 14.01. If you get higher or lower, it doesn't matter for now, because the final exam is how much? So start preparing from today for the final. Okay? 35%. Okay? And it will not be easier than major 2. Okay? So start preparing from today. If you don't understand concept, لا تقدرون تفتحوا المقاطع الكويتية. Okay? الكويتية is teaching another course. And now we are teaching EE for ME. She is teaching EE for EE. You can watch مقاطع دكتور عطية, مقاطعي, بس الكويتية she is adding an unnecessary noise, okay? It's designed for an EE مقاطع الكويتية. Okay? As always, we update the slides, okay? Every time, look at the latest version, get the PDF, or watch directly. So last time, we talked about the Zener diode, okay? I made a mistake, not a mistake, but somehow not good visualization of the problem. So remember the regulator circuit? It says here variable supply. This is a variable DC supply. Okay? So always the voltage here is what? Positive. So if the voltage is 0.1, what's the output? VZ. Okay? Now, depending on the Zener diode, if the VZ is, now because it's connected this way, the output is negative of the VD diode, okay? So if the breakdown is -2, so VZ will be +2, okay? If the voltage is 2, the output is -2. The voltage is 10, the output is -10, -2. The voltage is 20, the output is what? VZ, okay? Across the diode is -2, outside is +2, okay? So there is no AC signal in this circuit. This is variable DC supply. Go back to the Zener diode. So it's -2. So VZ is number 2. So if you apply anything above the -2 across the diode, the output will be what? No, 2 plus 2. Across the diode is -2. If it's -20, you have to reach -20. Anything above -20, the output will be what? -20. Across the diode, or +20 out the output, okay? Keep in mind for the Zener diode, if you apply voltage less than -VZ, the diode will be open circuit. If the diode is open circuit, the output matches the input. Okay? So how to draw this? V input, V output. So V output is what? -VD. Okay? If you apply anything above VZ, the output will be VZ. If you apply anything below VZ, the output will match the input. Get it? Does it make sense? Let's pretend VZ is 2 volt, okay? If you apply 3 volt, you're applying across the diode -3. So what will be the output?
3.
Across the diode is -3, the output will be, no, -2. -2, the diode is on. The diode will act as a battery when it's on. Okay? So if you apply 2 or 3 or 4 or 5 or 20, as long as it's above VZ, the output will be fixed, VZ. Here we have regulation, okay? Which is equal to diode on as battery, okay? Of VZ. Anything below, the diode will be off. So the output will be open circuit. If you apply 1 volt, the output will be 1 volt. If you apply 0 volt, the output will be 0. If you apply -1, the output will be -1. Up to -infinity. But this circuit is not practical because you need to change the variable DC supply, and in AC it will not work. Okay? Did I open the recorder? Yes. Get it?
So كيف نحدد الفي زد؟
It's by the data sheet. From a data sheet. VZ could be 2, could be 20, could be 250, depending on the application. Okay? Let me explain one more time. Zener diode is a diode intended to operate at the reverse region, okay? If the voltage is below -VZ, the diode will be on. If the diode is on, it will be replaced by a battery of VZ. So anything above VZ, if you apply it here, إذا حطيت أي VZ أو أكثر, this will be a battery of VZ. This will act as a battery. This will act as a battery, okay? If you apply anything below VZ, keep in mind the diode is flipped. Below VZ, the diode will be off and it will be open circuit. If it's open circuit, كأنها في ثفنت. كأنها في ثفنت. The output matches the input. Okay? That's what matters about the Zener diode. Let's go back to what we talked also about the practical application. We talked about rectifier. So the rectifier converts AC power into DC power. In this circuit, last time we talked about if you apply a positive voltage at the positive cycles of the AC signal, this is AC now. The positive cycles, the diode will be on and it will be like a short circuit, so the output matches the input. If you want to use the ideal diode model, if you want to use the 0.7 model, the voltage will be slightly dropped by how much? 0.7. For simplicity, let's pretend it's just ideal diode, okay? Then we added the smoothing capacitor. What does smoothing capacitor do? At the positive cycle, only the first one, 25% of the whole cycle, it will charge. The moment it drops below the voltage, now capacitor is fully charged. If it drops below the fully charged capacitor voltage, it will go down, discharge, but the diode will be off. When it drops below the peak, then it will turn on until it reaches the previous held charge, الشحنة المتبقية, then it will turn on. So here it's below 25%. The first one is 25% on, here maybe 20% on. until it reaches the peak and then starts dropping and it will discharge. How to determine the discharge rate is the value of the capacitance. If it's big, we expect this to be more flat. If it's too small capacitor, it will discharge very quickly and then charge. Okay? So the equation to calculate how much capacitor is needed is I of L, which is the average current, times the period of the AC voltage divided by the ripple voltage. So let's introduce the concept of a ripple voltage. What is a ripple voltage? The ripple voltage is simply the distance between this peak the voltage after charge, maximum charge, up until discharge. This is what we call it V ripple, and it's peak to peak. Tamam? So this is V ripple, it's peak to peak. So if it charges, up until it discharge, this distance, this voltage, من هنا إلى هنا, it's called the ripple. And how to calculate the ripple? You have to use oscilloscope and you have to measure it. Once you know the ripple that you desire, if you want a small ripple, what will happen? If you want a small ripple, capacitor value will be large. If you want big ripple, capacitor value will be small. Of course, if you have bigger current, you are charging faster, so bigger current would lead to bigger capacitor to charge, and the period of the voltage, if you want to store over a longer period of time, you need bigger capacitor to store. Okay? Now, of course, in design you have to fix. You have to fix 2 or 3 and then choose one. Yes?
هلا قد بس سيريز مع الذي نفس الفكرة؟
No. No, if it's in series, it will not. It has to be parallel. Okay? For the smoothing capacitor. Okay? The full wave rectifier. So let me just make sure I covered all the points. Because of the previous waveform is not pure constant. It has average DC, it's not smooth, so we want to smoothen it, okay? One approach is to use large capacitor in parallel. We explained if it charge, discharge, once it drops below the peak, the diode will turn off. This is very important. Once it drops, the blue signal drops below the peak, the diode will turn off, and then the capacitor will start discharging. Okay? Because of the charge and discharge cycle, the load voltage contains a small AC component called what? The ripple, which is the peak of the sinusoidal signal, the distance between the peak and the maximum point it was discharging before it began charging again. The average voltage is supplied to the load if a smoothing capacitor is used is approximately midway, so you can approximate the voltage to be what? Halfway of the ripple. Halfway of the ripple, that you can assume, so it's V maximum minus V ripple over 2. Okay? V maximum over V ripple over 2, which is somewhere, maybe here. Halfway. I want to draw a line, maybe it will be like that. That's what we call it VL, approximation. Okay? Somewhere between the max and the lowest bar, or the lowest point of the ripple. A good starting value for calculating the capacitance, you can use this equation and see how it performs in the simulation, and then you can make it bigger or smaller. Okay, Jihad? Full wave rectifier. Previously we had half wave, means we forget about the negative cycles of the signal. But for now, we are wasting energy, so why not have another diode configured. So we have two diodes, one for the positive cycle, one for the negative cycle. And you have two sources. You have two AC sources. The first source, only at the positive halves, this diode A will be on. So diode A will be on, diode A will be on. You can draw a cable or have another source that is flipped. Polarity is flipped. So now the negative of the negative is what? Memory positive. So this diode B, he is looking at the negative terminal of the source during the negative cycle. So what it will see? It will see as positive voltage. So diode B will be on and it will conduct current across the load. So during diode A is on, the current will flow here. When diode B is on, the current will flow what? There. So in either cases, the direction of the current is from top to bottom across the load. One time it goes here. When diode B is off, when diode B is on, the current will flow here. This way you have bigger signal, bigger power in terms of power. So the power of full wave rectifier, is it larger or smaller than half wave rectifier? It's larger. So when we ask questions in the exam, we may ask you to plot what is Vm. So Vm here will be reflected there. And then we'll ask you what's the charging capacitor, etc. Okay? Maybe we ask you what's the current. What's the current? VL over RL. This is one of the tricky questions in the exam. YouTube. Okay? But what's the problem with this circuit? You need to have two AC sources. It is not practical. So another solution is to use the diode bridge. GISR. So the diode bridge, you need to pay a cost of having how many diodes now? 4. And I told you, which one is more expensive, Zener or regular? Zener. So we use regular here. Remember, you only use Zener diode if you want it to operate as a battery that is flipped. يعني لما تقلبه. If you want a battery, you use Zener. This is VZ, this is VZ, this is VD. So VD equal minus VZ. Of course, VZ will be positive because by nature across the diode it will be negative. So if you want to get a battery, put Zener. Do we need batteries here? No. We don't need a battery here because this is AC signal. So we use the regular diode. So which one is cheaper, having 4 diodes or 2 AC sources? 4 diodes, because AC source is expensive. Let's continue. When the AC voltage source is positive, current flows through diodes A, okay, and then go to the ground, comes back from the ground, across B, go back to the source. So diodes A and B will be on. Let me repeat. ليه صح؟ ما حضر. Ibrahim, you always cause trouble to me. أنا مش شايفك، ما شفتك. بس ليه؟ جايبتها ليه أساسا؟ لا. Okay. So let me repeat. At the positive cycles, does AC positive? Yes, so it turn on. Okay, replace it with a short circuit. Diode D and C, they see positive at the cathode, so keep them off. So they're going to be open circuit. So the current will flow where? To the load. Once it goes to the load, it will go where? To the ground. بيطلع لك من الجراوند. Still this is more positive. This is 0, this is negative. Is 0 larger than a negative?
Yes.
So this will turn on. It will go back to the source. Keep in mind the source here is not connected to the ground, the negative of the source. Ground is halfway between. So what will happen here? We will have, when at the positive cycles we have a load voltage, okay? At the negative polarity, if this source is negative, we have more negative at the cathode here than the anode. So A will be off, B will be off. So the current will, this diode will be on, this diode will be on. So the current flows through the negative cycle here, the negative part. Because this is more negative than this. At the negative AC, this will be more negative. يعني هنا minus, amplitude is minus 10. So it will go here to the ground. Where is it connected? It will go here. Oh, they connected the ground to which diode? C. So it will go through D, R load, go back to C, go back to the source.
This is another one.
No, this is during negative half cycles. هنا في positive cycles of the source, في negative cycles of the source, those two diodes are on. You don't need to understand the details, but you need to understand that at the negative cycles, I have a current flowing here, go back, so from D to C. Positive cycle from A to B. Okay? So now we have a rectification of both the positive and the negative signal. Okay? So full wave rectifier with smoothing capacitor, we can also add smoothing capacitor. Where do we add the smoothing capacitor يا ابو نصار؟ عالم ثاني يا ابو نصار. Where do we add the smoothing capacitor? This circuit does have a smoothing capacitor. This circuit doesn't have a smoothing capacitor. So where did we add the smoothing capacitor? Look at the difference between this circuit and this circuit. Parallel to our load. If you look at the second circuit, we added the smoothing capacitor where? Parallel to the load. Parallel to the load, okay? Abdurrahman, parallel to the load. If we add a smoothing capacitor, the only difference between full wave and half rectifier, half wave rectifier, is there is a half divided by half. So in the full wave rectifier, you need a capacitor half the size of the half wave rectifier. Remember the equation for the half wave without divided by 2. Full wave rectifier, you need to divide by 2. Why? Because the capacitor is smaller, because I'm making use of the negative cycles now. Okay? Key important is to understand it, Turkey. Okay? Okay. Key important is to understand why the capacitor in the full wave rectifier required is half the size of the half wave. Why?
Because we don't need the same.
No. Because in the full wave rectifier we use the negative cycles. That's the right answer. Okay? شاحن الجوال. This is the circuit of شاحن الجوال. Do you remember the transformer?
Yes.
Ibrahim, what was the purpose of the transformer? I cheated you during the quiz. غششتكم في الامتحان. To change the voltage levels. either up or down. So how much voltage you get here? Well, this is 220, this is 110, so this is 220. Standard, like in 220. So let's say we get 220. Put it in the transformer. What's the voltage here? 5. It's AC or DC here before the rectifier? AC. AC. So في شاحن الجوال you start with 220 sinusoidal, then you use transformer. How much you get? 5 or minus 5? AC, صح? Then you apply, this is the ABCD, full wave rectifier or half wave rectifier?
Full wave.
4 diodes يعني full wave. This is, what is this capacitor يا ابو نصار? C1. C1 و C2. Okay, what is C1? Why do we have a C1 capacitor here? Smoothing. Smoothing capacitor, تنعيم.
Both of them?
Well, one of them is smoothing capacitor. The other one with another chip, it's called the voltage regulator. What is the voltage regulator?
Make it
steady.
Zener. Chip, some chip, 7805. Integrated circuit. But this one is to improve the quality. But this capacitor is the smoothing capacitor. This capacitor is for, it could be another smoothing, it could be filtering, I don't know. But what I want you to know is this capacitor is smooth. Okay? Note that, Nasrallah, this is 1000 microfarad, this is 0.01 microfarad. So this one is much larger. So which one you think is?
the first one.
This one is the smoothing. This one, it can be smooth, the smoother. But this is a voltage regulator, it could be Zener, feed Zener داخله. This is to improve the quality. But up until here, this is the output you can get. So when you apply full wave rectifier, ايش يصير? Like that, صح؟ بعدين نعم الموجة smoother, smoothing signal. What will happen to the smooth? This is almost 5 volts. Okay? So how many stages of شاحن الجوال? 1, 2, 3. T, R, S. Transformer, rectifier, smoother. T, R, S.
بس ما وصلنا للدي سي الحين.
Almost DC. عشان كذا نحط هذه الشيب to improve the quality of the signal. اللي فيها زينر إذا حطيت عليها زينر خلاص تصير almost DC. يلا نحط last step زينر خلاص مضمون DC.
كان بيصير الربل تقريبا.
5 volts exactly. فتحة الايفون 5 فولت. عشان كذا يا شباب always buy expensive charger. Why? Because the cheap charging خصوصا الراس الكيبل تمشي يعني تقدر تشتري واحد رخيص يمشي بس الراس حق الشاحن if they give you worst thing they give you a cheap transformer. If they give you a cheap transformer maybe you will not get 5, maybe you'll get 4.7, maybe you'll get 6.3. It's not perfect. The windings, they are not really perfect to match the source. The source is perfect من شركة الكهرباء. So they become cheap here. Also they become cheap على rectifier. They give you cheap diodes. Not 0.7, maybe they give you 0.4 diode. It can also reduce the voltage. Maybe it will be 4.8. وين بعد يلعبون؟ يلعبون charging capacitor smoothing capacitor يعطيك واحد رخيص صغير فما يصير فيه enough smoothing. ممكن ما يحط لك ال 7805 chip يسحب.
هذا ريجوليتر.
ممكن ما يحط لك ريجوليتر يقول مشي.
The whole circuit here, doctor, is the head, right?
هذه كلها هنا قبل اليو اس بي. عند اليو اس بي تاخذ السيجنال 5 فولت. This is very important slide. Okay? Exercise. What are you going to do at home? Open one of the chargers. Look inside it. Okay?
تمام.
Throw it خلاص. 30 ريال شيء. الأشياء القديمة يعني. Okay? A numerical example. This is a clear numerical example. A power supply circuit is needed to deliver 0.1 and 15. So 0.1 amps, what's the current? 0.1. What's the voltage level? 15, not 5 volt. AC source has a frequency of 60 hertz. The circuit, so why we need 60 hertz?
Saudi.
Maybe we don't need it, but later if we want to have a circuit, we can calculate 1 over j omega c. That's why they give you the frequency. Assume that the circuit figure is to be used. A ripple voltage peak to peak, how much? 0.4. Peak to peak, ripple. الباند حقت الرipple 0.4. Instead of assuming ideal diode, allow 0.7. Use the 0.7 model. So what will happen if you use the 0.7 model? 0.7. We design for a peak load of voltage. So we have We have 15, then we have a ripple of, ripple is 0.2 or 0.2, يعني how much? 15.4. We need to have the design. Here 15, then we have 0.2 up, 0.2 down. So 15.2, I'm sorry, 15.2. So as suggested in exercise, we designed for a peak load of how much? 5.2. The AC is 15, but عندك 0.2, half of the ripple will go up. So 15.2. Not only that, you need to add the 0.7 drop. حق الدايود. So you have 15 plus 0.4 over 2 plus 0.7. How much is that?
Minus. Minus 20.
No. No, you need to add it.
هو يبغى البيك هذا شيء. وين سمعنا قبل؟
Well, this is 15, this is 0.7, so you need to design for 5. Okay, هو يبغاه هنا, but you need to design plus 0.7 because,
We will lose 0 minus.
well, let's write the equation. VL, voltage rise, plus V diode, minus Vs, equals 0. This is your VL. Okay, you design with VL. So Vs is already incorporated في 15. Well, if you subtract it, then you're under designing, that's the problem. It's not KVL, KCL. You look at how much voltage is needed to turn on the diode.
I think because we're losing 0.
No, I can answer this question. To turn on this diode, you need to have 0.7 higher than the here. That is the reason. You do not use KVL. So you need to make this, so if this is 15, you need to design your capacitor assuming that the voltage will turn on this diode. It will withstand the voltage of 0.7. So I think just add it. You can't subtract. If you subtract, you will lose the features of the ripple, the peak of AC signal. So you need to add the effect. So just add it, 0.7. Do not subtract, as the book said. Okay? It's not clear KVL, but it's just basically to turn on this diode, you need another 0.7 voltage. Even though the source is going to be 15, so you need to design it for the worst case scenario. We're designing for the worst case scenario. Then apply the numbers. 0.1 times 60. Oh, now we know why we have the frequency. Frequency is 60. What's the time period? 1 over 60. So what's the value of the capacitor? I M times T divided by V, not V ripple. Yeah, V ripple. So it's going to be 0.1 times 1 over 60 divided by 0.4. That's 4167 microfarad. That's your C. Well, this information is irrelevant of designing the capacitor. Okay?
But sir, I think I understand. Because we change the ID to voltage source, it will be plus minus 0.7, and I think we can make it.
Well, read the question. It says find the peak AC voltage needed. So what's the question asks find the peak AC voltage needed. So it is 15, but you need plus 0.7 to turn this on. So you need to add 0.7 to turn the diode on. That's the right way of thinking. So we design the capacitor, and then we calculate the maximum or the peak. Now this is for the half-wave rectifier. What's the value of the capacitor for the full-wave rectifier? For the same circuit, divide by 2. For the full-wave rectifier, just divide by 2. Okay?
دكتور 15 فوق ما البي.
No, the question is asking you, you need to come up what is the source needed.
Okay.
So you want 15 volt here. Because you want 15 volt here, you need a ripple of 0.4. You need a 0.7 to turn on the diode. So your source should have a peak of 15.9. Get it now? So you're actually designing for VS. VS is not 15, 15.9. 15.9 minus 0.7 will give you 15.2, which is VL. Okay? For the full wave rectifier, the value of the capacitor, it will be half. So 0.160 divided by 2 VR, which is half of what we had before. For this circuit, the voltage is 16.6. I think it has, what's the only difference? Okay. For the circuit or figure, we need to allow for 2 diode drops, not 1 diode drops. We need diode A and diode B, diode C and diode D, so you need to add 15 plus V ripple over 2 plus 1.4. That's why it's 16.6 for the full wave rectifier. But what are you benefiting? You're getting a capacitor that's halfway size. Okay? Okay. For wave shaping circuits, we need an additional lecture. Okay? We will not be able to cover it today, and we have vacation Thursday, right? Thursday. For the major. So we have to have another online lecture at some time next week. Okay? We'll make it online, we'll record it, no attendance. Just extra, something extra to explain the wave shaping circuits. So we have 5 minutes left, so let me go and do a quick revision about what we covered today. So what we covered today at the beginning, we reminded ourselves about the Zener diode. We talked about the Zener diode. If you apply for the Zener diode, if you apply a voltage across the diode, negative of, like if it's -2, if you apply -3, -4, -5, the diode will turn on and it will be acting like what? A battery. We provided the example of this circuit and we say variable DC supply. If you apply, if the VZ is equal to 2 or -2, minus VZ is -2. If you apply 3 volt, what will be the output here? 2. If you apply 4, what is the output? 2. If you apply 10, what's the output? Still 2. If you apply 0, what's the output? The diode will be off. No, 0. If you apply 1, which is less than VZ, which is 2, what's the output? Still 1. Remember, straight line at lower voltages. Then we talked about what? Half-wave rectifier again. We said half-wave rectifier, only the positive side signals get kept. We chop what? The negative half cycle. Because the diode will turn on for the positive cycle. Then we talked about smoothing capacitor. We said that what's the benefit of smoothing capacitor? It will reduce the on and off time and it will make the signal closer to DC. So turn on, up until reach the peak, the diode will turn off, start discharging, and then until we reach it again, it will start charging. The value of charge discharge would determine what's the slope of your line, and we say the equation is ILT over VR. Then we talked about the full wave rectifier. Jihad, the full wave rectifier, 2 solutions, one to use 2 sources and 2 diodes, but this is not good because we cannot have 2 sources, it's too much. So we said it's better to use what? 1 source and 4 diode. At the positive cycles, A and B are on. Negative cycles, C and D are on. Positive cycle, the current will go here, go back to the ground. Negative cycle, the current will go here, to the load, go back to the source. And what is the benefit of the equation of the capacitor here? The capacitor will have divided by half. Why? Because we are having 2. We're using the positive and the negative side. So no need to charge more. Abu Nassar, where do we apply the smoothing capacitor? When نحطه؟ Parallel مع اللود. Parallel مع مين? When we explain the most important slide of today, what is the most important slide? We can leave. The charger. Again, smoothing capacitor is parallel. Any question?